Okay, in this example, we're going to find the Laplace transform of t squared times the delta function at t minus 4. And to do these problems, we need to go back to the definition of the Laplace transform from the first section of this chapter to actually do this problem. So going back to that definition, remember we've got the integral from 0 to infinity of our function f of t, which in this case is t squared delta t minus 4, always times e to the negative st dt. Now, in these problems here, we notice that the definition of the integral above has a negative infinity, but remember the function is equal to 0 outside of that. So we can just use the 0 to infinity definition as well, since we're integrating 0 still gives you 0. So the next step of this problem is to go in and rewrite this so that we've got the integral from 0 to infinity of delta t minus 4 times now t squared e to the negative st dt. And now we're going to use this definition above, and this here is our f of t in that formula. So when we go through and actually find our Laplace transform, it's going to be that function, f of t, evaluated at the number p equals 4. So that's going to be equal to 4 squared times e to the negative 4 times s, which is just 16e to the negative 4 times s. So that is the Laplace transform of the function.